Hey guys, I hope you're doing fine. Today we're going to talk about isosceles triangles. You already know this. Isosceles triangles are triangles that have two equal sides. Here is an example of an isosceles triangle. This triangle has these two sides congruent. The congruent sides of an isosceles triangles are going to be called legs. Now, the point where the two legs meet is going to be called the vertex. And in this vertex, you can see that there is an angle being formed. This is called the vertex angle. Now, there is one of the sides that is different because those two sides are congruent. The different side is going to be called the base of the triangle. All right? And this base connects two different angles. If you notice, these two angles are the opposite angles to the legs, always. These are going to be called base angles. All right? Now, let's talk about a little bit more of isosceles triangles. There is a theorem, it's called the isosceles triangles theorem, that explains how is the behavior of the angles and the sides and the relationship in isosceles triangles. This theorem says the following. If two sides of a triangle are congruent, then the two angles opposite to these sides are also congruent. Let's take a look at it. If two sides of a triangle are congruent, so here I have a triangle and these two sides of the triangle are congruent, okay? Then the two angles opposite to these sides, let's see who are these angles opposite to these sides. This side over here, the opposite angle is this one over here. And this side has an opposite angle, which is this one over here. So if two sides of a triangle are congruent, these two, then the two angles opposite to these sides are also congruent, saying that these two angles are also congruent. All right? Now, we're going to go with the converse of the isosceles triangles theorem. This is the theorem, and this is the converse of the isosceles triangles theorem. The converse works just the same, but in the opposite way. What is that going to sound like? It says, if two angles, so here we started with two sides, then we're going to start with two angles. If two angles of a triangle are congruent, then, so here we said, if two sides are congruent, the opposite angles are also congruent. Now we're going to start in the other scenario. If two angles are congruent, then the opposite sides, the sides opposite to these angles are also congruent. All right, let's see how it looks like in the drawing. If two angles of a triangle are congruent, so let's suppose we have this angle over here is congruent with this angle over here. So if we have two angles of a triangle being congruent, then the opposite sides to this angle, the opposite side to this angle is this side over here, the opposite side to this angle is this one over here, are also congruent. Okay? That is going to help us make a lot of relationships between isosceles triangles. Now, let's go ahead and solve example number 1. Those are triangles that have two equal sides. So here, nobody's talking about sides. We need to find out if the sides are congruent or not. Now, in order to find out if the sides are congruent, I could use the converse of the isosceles triangles theorem that says that if the two triangles of the base, the two angles of the base are congruent, then the opposite sides are also congruent. However, we don't know the measure of this angle, so we would have to find it. Can we find it? Let's see. Go ahead and do exercise number 1.